before you start, you just need to sort of tell everyone we're going to start recording, and this is for internal purposes, so it's not going to go on the website. So if you don't want to be recorded, just switch off your video.
Is everyone okay with that?
Yeah, that's
Good.
Cool.
Oh, so we'll just wait for the next few people and you're good to go.
Valerie, I'll set up a Slack channel for this, like we were doing yesterday, and I'll add everyone onto it.
Oh, that would be perfect. Thank you. So you'll find this if you go onto the IDP, forget what it's called, workshop discussion groups or something, the Slack channel that you should all have access to. Anybody who doesn't, let me or Kira know, but I think you all do. And we'll set up a particular channel within that for this particular discussion group, so we can put references and comments, anything up. We'll be doing it gradually for all the discussion sessions as time goes on. So hopefully that will be useful. But do shout if you can't find it.
Cool. Okay, well, do you think we're ready to start? We can start sort of gentle, so if there's any latecomers, they can sort of pick it up.
And they can always watch the recording. So.
Yeah, that's right. As scintillating as it will be, they can always watch that.
Yes,
Okay, cool. So everyone's okay with us being recorded now, because we're now about to start for real. Cool. Okay, so it's nice to see a few faces here. I guess there's several things we can talk about today. First of all, just the general title of this sort of section, which is estimation brackets uncertainty quantification, which is interesting all by itself, I think. Now, I think the sort of various sections for these challenge papers are sort of suggestions. So obviously there's a sort of discussion to be had there about exactly what this section is trying to do and whether we agree exactly with that title. And then there's a subsequent discussion of kind of, what actually are some of the details we can actually offer, we can kind of add. Now, obviously, I think if any of you have heard me rant on any of these I&I meetings before, you probably know I come from a sort of UQ sort of background. I'm a Bayesian statistician. We work on complex physical models. We do a lot of kind of emulation to mimic an expensive model, but we do uncertainty quantification, which pads everything around with uncertainty statements, kind of, sort of interior to the model and exterior, and linking the model to reality. That's our kind of remit. So my apologies if a lot of what I say kind of comes from that direction, but that's kind of where we're from. So I welcome lots of other opinions from other sort of places and directions, et cetera, et cetera, et cetera. But I think we should just talk first of all about the word estimation, because I was not in the room, I think, when these topics were split up, and that's fine. So I guess, first of all, I would think we should talk about, well, get a few views from people about what we think is meant by the sort of term estimation. How wide is that remit? For example, just to throw down a few sort of markers, estimation can mean broadly, a lot of stuff, right? So we could interpret it to mean we want to, estimate the future, things in the future, as in turn it into a prediction question. How do you use models to predict the future? Or we could turn it into the kind of, which is perhaps the sense it was meant in terms of gathering data to then input into one of our disease models, for example. So a sort of elicitation, estimation, a prior analysis that you do to gather the pieces you need as part of your model building construct. But there's many other interpretations, or for example, estimating model parameters, for example. So can we just have a few thoughts from people? I don't want to sort of jump the gun and get straight into what I want to do, basically. I want to hear some thoughts from some people. So would anyone like to say what they think it means, or what they think we would like to do?
Can I kick off, because I have to leave at 10?
Good idea, Peter.
Go and do an interview or postdoc. So I think one of the things that struck me talking to epidemiological modelers during the summer is there's quite some resistance to uncertainty quantification for reasons that I think I'm starting to understand. Modelers never like to do uncertainty quantification, whatever subject it's in. But I think there are things that sort of hide uncertainty quantification, and that's partly because the models are stochastic, and there's a feeling if you estimate the amount of stochasticity, if that's a word, in the model, you've done the uncertainty quantification, which happens. You've only estimated part of it. And estimation error, when you do an ABC or an MCMC, you get a bound, an error bound distribution of your model parameters, and that looks like uncertainty quantification as well. And I think if you look at Ronnie Bowman's paper, where she looks at all the SPI-M models and tries to produce a sort of joint model, and she throws away all the second order stuff because they're just inconsistent completely. Because some people have estimated the stochasticity and some people have estimated the estimation error, and some people have tried to do a proper uncertainty quantification. And I think within the subject epidemiological modeling, there's a lot of confusion of what uncertainty we're trying to get. And that means that people produce different things. It's very hard to have a proper conversation about that because we don't define terms properly. Or in general, terms are not defined properly. And I think we have to step back and set out from first principles what we're trying to do. And if you do that, it becomes more obvious, hopefully, that there's a problem of how you estimate parameters. Now we call that calibration, sort of calibrating the model. And I think that's a lot of what people say by estimation. They want to estimate the parameters of their model from the data. And they do that with ABC or MCMC. But that's only half the battle, because it doesn't have any model discrepancy in it. It doesn't include the uncertainty coming from other unknown parameters. I mean, the imperial model has 900 parameters. Now, a lot of those probably do nothing, but some of them are important, and that brings the whole thing of sensitivity analysis to find out what's important. Uncertainty analysis, if they are important, what does it do? I mean, it brings up the whole thing, but I think in general, it's not done, it's not thought about properly, because modelers model, and that's what they should do. They don't think about uncertainty. And hopefully we can lay that out in a rigorous way that everyone's going to say, oh, yes, we should do that, rather than well, you ask the questions at the end of people's talks the same way I have. How do you do uncertainty? And they don't. Anyway, I shut up.
No,
If I may pick that up, Ian, this is just Mina, and I'm in. If it's okay.
Please, of course. Please go ahead.
So I'm an epidemiological modeler. So thank you, Peter, for highlighting this, because I think it's really important, and it is something that that I think it's not talked about enough. You really highlighted the calibration uncertainty and the robustness of model uncertainty. That are two separate things. Just to highlight, there is two things in the pipeline that I have planned. One of them is to take a set of models that you would have heard of, that are part of SPI-M, that are part of sort of informing policy decision currently, and ask them to answer two specific same questions by varying the same parameters and seeing how the uncertainty range, or the range of outcomes for those questions, varies with a median and a mean for each of the models. So that's a separate thing, that an exercise I'm trying to do with a huge group that I recruited at a workshop last week. The independent of that, there is a sort of challenges of modeling study that Valerie and you probably a lot know, that we are going to talk about later on later on today. So at 3 o'clock there is another session on challenges, and the idea is that we need to consider untangling uncertainty in estimation versus uncertainty in modeling. Now, both are important, but they're different concepts. This is what I want to highlight. So everything that Peter said, I consider as a challenge of modeling related to uncertainty of model outcome projections. What I thought this was about estimating with uncertainty from uncertain data and in the calibration process. So just highlighting the two differences.
Could I just sort of chip in there? Just say a little bit about the background. When we were trying to sort of divide up the whole area of what we've talked about over IDP over the last 6 months, you know, obviously models and estimation is a big area. We decided, you know, for the purposes of these initial discussions, to split it because it's too big. Modeling, even without all the sort of estimation things, is too big. How estimation works is up to the people involved. I mean, where they see the challenges, and I think things may well move around from place to place. I mean, these were just initial starting points. We tried to find a couple of people who would be willing to sort of kick off with a few ideas for the discussions of each one, just so that we didn't all sit here sort of mute. And we asked therefore Ian and Phil, who are both very interested in different aspects of estimation, who both kindly agreed, but obviously they have their own focuses. Particularly Ian was very upfront about saying, but I shall bias it towards UQ. And I think the only concern is that if we've got UQ and we've got expert judgment, there's a lot of other estimation to go in there as well somewhere. So I don't think anybody should feel constrained that this discussion is on this and this afternoon's is on something different. I mean, we just need to get the challenges out there and start thinking about them, and then we can rearrange.
So then maybe just to say, so then maybe we should just identify then what is the main message that each paper wants to say, and then work backwards as to how do we answer that question. I don't know, that's one way to think of it.
So
can I just say, I think in the last 6 to 8 months, we've had no shortage of estimation. I think we've had a critical shortage of uncertainty quantification. We've had a lot of models, we have a lot of predictions, and being able to sort of say where can we have a level of certainty to be able to make decisions and reduce risk has been the shortfall. So in my view, I think we should focus very much on the uncertainty. That is the key issue that we need to crack. And my view is if we say include estimation, we dilute what the main message is. We've got to somehow sort out which models we believe and which data we believe, and embrace the fact that we've got incomplete data, we've got uncertainty, we've got confusion. How do we bring that together?
yes, if I can just...
Sorry, you're putting your hand up. I'm not chairing this, so no, I think you are.
My hand up is just to warn people that I'm about to jump in because I'm the chair. Don't worry. So it's just to warn people that I'm about to start talking, that's all. No, listen, these are really nice points. Thank you, Jasmina. What you're saying about comparing multiple models is very interesting. And Valerie, what you're saying about the sort of original estimation sort of goal is interesting. And Peter, yes, this is the point. There's two things going on here, right? UQ methods have lots of nice things you can do to help estimation, right? So there's techniques which help with that particular goal. However, really the beauty and strength of UQ is the underlying framework that it gives you to handle all the types of uncertainties that you think are important. And I use that word all deliberately because UQ gives you an embedding framework where you put in your model or other people's models, and you put in reality, and you put in all the possible things that causes these to be different, because all the models are not the same as reality. And in fact, that is the problem. And this framework, then, it gives you an underlying structure. So when you want to do something, for example, maybe your task is estimation. Maybe let's take the classical sort of, I want to estimate parameters of my stochastic disease model. The problem is, and this is my problem with just identifying this group as just doing estimation, is that naturally begs the question, what are all the other uncertainties? So I don't think you can do a very robust and rigorous estimation game without using a full UQ structure, which allows you to bring in properly the uncertainties from the observed data, which is uncertain, from the fact that your model is in some sense slightly deficient. So it's a little bit wrong. So it has, you know, correlated errors over time. So to estimate parameters of your model, you kind of need the UQ structure, I would suggest, to do that correctly. So that this is the difficulty we have, is that it's hard to piece things up and just to say, we're going to look at just this without the underlying structure. But the thing is, as Valerie says, we're in this sort of flexible game right now where we're just trying to design these different papers, which will be great. So I just want one thing for people to hold in their head is that UQ is this underlying structure, and we can talk more about that if we need to. But the key thing is it highlights that difference between model and reality, which resolves a lot of these issues. Jasmina, your issue when you're combining lots of models together, incidentally, is you need some underlying structure which says each model is here. They're all different and they're different from reality. And that structure is the one which allows you to combine them together. So it's all very nice. But so UQ offers that structure. And then there's a separate game of estimation. So, and this ties in with this afternoon's meeting on modeling, of course, because when you talk about modeling challenges, part of modeling, of course, is to then estimate things in your model. Part of modeling is to determine how close you are to reality, how far have you got? And then this allows us to do what Peter then mentioned there, which is the key point really, which is to make projections into the future that in some sense you trust. So uncertain statements about future state of the system, and then decisions that you actually think you can act upon. And that has to be done within some larger framework. We can't just run a model into the future and say, if the model assumptions are true, I would do this. That is not a strong enough statement for what is needed today. So, so maybe we need to split or diverge, or maybe there's some discussions this afternoon. I don't know. Does anyone have any thoughts they want to add on that sort of stuff?
I don't think it's a split. I just think that the focus is on the uncertainty, and whether that's through a framework or just embracing uncertainty is the important thing.
Mm-hmm.
Yeah.
And I completely agree. I think if we call this, if we have a paper that literally has how uncertain are our model predictions, that would be exactly what we could address with a different layering of uncertainty. And then we would have potentially another paper that says how much do we trust the model, but that doesn't discuss the uncertainty, but discusses the model outcomes that come from different, and how different. And as Peter mentions, if we have an agent-based model, we have a high level of stochasticity and noise in the predictions. If we have an SCIR model that just has fixed model parameters, we just have one trajectory that at the sort of mean value should converge to each other, but often they don't. So why not? Those are two papers that, or two sort of answers we want to give that are linked but separate in my mind.
Mm-hmm. It's interesting, isn't it? I mean, I could imagine a paper where we lay out the formal structure. When I say formal, it's not too formal. It's not pages of mathematics, but we lay out the formal structure of the sort of bare minimum pieces of analysis that we would like to have for it to be, you know, a standard that we would be sort of we'd find acceptable. So there are these particular pieces in a UQ structure without which you can definitely point to someone's analysis and say you're going to make this sort of mistake. So we could have a paper which lays out that structure, and then which talks about, you know, the necessity, why each piece is there, and the sort of problems you will get if you ignore it. So, for example, I think it's pretty, you know, well accepted that if you ignore observational error, for example, you will in some sense make some mistakes. You'll be overly certain, etc., etc., etc. That's pretty sort of well known in a sense. However, the statement that if you ignore your model discrepancy, so that's the upfront acknowledgement that your model is different from the real world, and it's different from the real world in a way which is totally different from your observational error, which can often be noisy, sometimes unstructured, depending. Your model error is often structured, heavily correlated over time. Your model is missing, it's undershooting for the next 2 months, say, for example. So the ignoring of these types of uncertainty damage your predictive capability, they damage your decision making. So we could have a paper that kind of highlights the structure, targets and explains to people why each of these pieces are important, and then we could do something with it. We could either do estimation or forecasting or whatever. Michael.
Yeah, so I think part of the problem is that there's a development process here. So the end game has to be understanding how the models relate to the world and the full issues. But of course, as modelers do all this, they have to go through all sorts of processes first. So it's a perfectly reasonable question for two groups of modelers to get together and say, you know, why are our models disagreeing? What is it about them? What processes are different? And do they make a difference? So en route, there are many things that people are talking about, and you know, and they were saying, well, getting us to think about all these other things is confusing our brains because we're not at the stage yet of taking our model to reality. So I think that that when we think about the challenges, there's a whole development process, and that should be part of the story. I mean, I think that. I mean, UQ still has tools to help them do it. For example, if the models are complicated, building emulators is a good way to help people understand whether the models are really different or whether just that they're not comparing the right parts of the parameter space. But that's a different question. I think that you need to be clear about where we are in the process of doing something that eventually will help people.
And so there's several issues there to unwrap. I mean, I meant to say previously, related to Jasmina's comment, the issue of multiple models, of multiple groups models, for example, is very interesting and really highlights the need for some of these considerations. But we should make a decision because that is a whole game in itself. And it slightly relates to Michael saying, as you're saying, when you're in the development process and groups compare together, then again, the comparison between models is a very interesting game itself, but it is an extra layer of thought and complexity, essentially. But separate to this, Michael's pointing out what stage we are in the process. This is a good point. I mean, there are methods we can do to help model development. And then there are methods when we're at the final stage of actually, you know, giving predictions and decision support to decision makers. At that stage, we want to be linking the model to reality. I don't know where we want to sort of pitch this. Sorry, Ben.
Yeah, I think I completely agree with what you're saying there. And in addition to what Jasmine is saying as well, I think there's all sorts of decisions within model. So we've talked a bit about differences between models, but I think there's also within models, there's various decisions we have to make, such as spatial aggregation, temporal aggregation, and resolution. And these are all part of the uncertainty process as well. So I think if we start getting into that dimension, it becomes a whole different ball game. And I think, you know, that is a very interesting process in itself, and how we go about making these within model decisions or between model decisions, and the process we have to go through for that, and what the ultimate implications are on the outputs of our models.
Do you think some of this would overlap with the discussions this afternoon on modeling, the sort of challenges to modeling? I mean, I don't really want us to sort of come in and sort of say, oh, you know, part of this afternoon's discussion should be about what we do. But on the other hand, there's obviously a natural overlap with certain issues, right?
I think this is just Mina. I think it's important to sort of join them together and then separate them later on, because I think they link together. One other thing I just wanted to mention, I think in line with what you said was, how long do we predict for? So I don't just give you an example. So if you've seen my papers, they sort of initially what we were predicting as part of this informed policy decision makers was a longer time projection. What would happen over the next year? If you've seen the most recent studies about the circuit breaking, we are really projecting for the next 2 months. So and there is a reason for this, because the uncertainty of fitting a time series obviously increases if you increase later in time. In projecting for the next few weeks or next few months is has higher level of certainty, just because of how you constrain the curve and how you fit it, right? So there is that point, but I'm only saying that will be discussed in the challenging of the mathematical modeling and the concept of prediction. So we don't need to mention it here, but if we are making a line about uncertainty, we then link that towards that paper.
Well, this is the issue, isn't it? Is that will of course be a primary goal, I guess, of the modeling discussion this afternoon. Will be, you know, developing models to a sufficient level of accuracy that you can trust their forward projections, right? I imagine that would be a sort of, you know, part of their discussion at least.
Yeah,
But,
I mean,
but
there
of
are
course-
four challenges. I'm not going to go into them. I've thought a little bit about it. That there are four challenges that we need to address there, maybe more, four sort of broad levels. But let's go back maybe to here. And then, I mean, what about numerical uncertainty? Are there people who are experts here? So I can't see everybody, first of all. And secondly, I do not know everyone's expertise. But are people here who are sort of worried about the numerical robustness of uncertainty?
I'm guessing by the silence, the answer would be not so much. I mean, numerical uncertainty is important. When we talk about a full UQ analysis, if we think that is important, that would be a sort of feature in our model discrepancy, perhaps. But I guess it is a sort of area of sort of sub-investigation in UQ, I guess. And there's been some
because the important thing is that, you know, how you calibrate what you decide is your objective function, and how you minimize it in a way. It can be done in many ways, right?
Yes. Now that's a good question. A lot of the sort of full UQ approach should provide robustness to those sorts of issues. I mean, when you say numerical uncertainty, there's a few different things we can mean here, but the calibration sort of process, which we can talk through in more detail if you'd like, should give you some level of robustness if it's done sort of carefully. All these different uncertainties, once you put them in, it tends to make your calibration process a little safer and your future predictions a little bit more robust. But
I'm even mentioning a step before the calibration. So deciding on your objective function, is it for COVID, for example, is it deaths, is it hospitalizations, is it cases, is it all together? And which one is a more important constrained objective function?
Yes, so that's a very interesting question. That's definitely part of the deal. Would you not feel, I guess I would feel slightly unsettled if a group, for example, specified one particular data set and ignored the others, for example. So a full UQ analysis would say that we will take certain data sets because they're more trustworthy, because, for example, we suspect there are large systematic errors on some of the other data sets. So the classic one being cases, right? I mean, cases are dangerous to use because they rely upon so many unknowns: government testing procedure, have we hit testing capacity, et cetera, et cetera, et cetera. So a full UQ analysis would say these are the uncertainties we attach roughly to these data sets. For this one, the uncertainty is so large that we view it to be uninformative for what we're trying to do.
I have some more questions, but I'm going to let someone else speak.
No, sure. Thank you. Yeah, it's interesting. There's lots of different points here. Again, I keep coming back to the kind of framework, and until you have this overarching framework, there are lots of sort of confusing and slightly sort of different strategies which are slightly at odds with each other. So this is why we sort of push this. So I guess, you know, it's fairly clear where I'm coming from. I kind of want the framework in place, and then the question is, what do we then do with it from there? It would be my sort of view as to how we go forward. But
well,
I don't.
You have this overarching framework, and I think what we need to do is divvy it up so we know a bit more clearly what are the separate issues. Everything's connected, but I think it's rather important, nevertheless, to consider what are the different issues and what are the more specific challenges within this. And one of the challenges is putting it all together. UQ is very good at that, but you've got to have things to put together in the first place. So I think one of the tasks in sort of, deciding what the challenges are is to see at a slightly more granular level, what are we actually trying to do?
I guess I'll add to that, Ian. How do you visualize this paper? What is in your mind, sort of, what is this paper going to tell us? Maybe that's how we should do it.
Well, that's a good question. I don't really want to push any particular view, but I'll give a view and people can feel free to shoot holes on it. Absolutely. So one possible paper we could do is to say the UQ sort of aspect is useful for stochastic disease modeling. Here is the structure which we think is important and the reasons for the pieces. And there's things like, you know, the observed data with associated observed error estimated with care and attention and with structure. You have your model with its own stochasticity and structure, and it sits here. You have reality over here, and it is different. And we want to talk about the links from model to reality. Rah, rah, rah. That is the sort of structure we talk about. Or the model helps you calibrate its input parameters, but you calibrate via observations on your system. So it goes observation, system, model, parameters, and that's the inversion you're doing. That's the inference you're doing on your parameters. So for example, estimation of parameters has to come through UQ structure, has to have all these uncertainties in place. Okay. So the paper would lay out that framework, and would then maybe discuss each of these pieces and give sort of techniques of how to estimate or structure these pieces. We don't want to just say to people, or you just, estimate your observational error, go ahead. We maybe want to give them some structures, some pieces, some guides. So that sort of digs down a little bit, which what Philip was just saying there. We need to kind of dig down into these little areas in a sense. And then there's a choice. We could then say, okay, we're now going to show you why this structure is better at a task. And we could do a few tasks lightly, or we could do one task in detail. So for example, we could say how we're going to calibrate the model in a more robust way because we have this uncertain structure. And we're going to learn about that input parameter space of the model. So the model may have many parameters, and we're going to learn about the region of parameter space that is sort of consistent with observations in a robust way because of this structure. And we can show what you do without this structure if you just naively sweep aside half of this and do the standard inference that people try to do. And we could show how the results are different. If we want to go further, which is the real test, is we could show how the predictions in the future are different with and without UQ, essentially. And show how the predictions in the future without UQ will be narrower, will be essentially overfit, and there will be an artificial level of confidence, both in the parameters that you learn about, because you tend to make that posterior distribution, if you will, tighter if you don't have the relevant uncertainties in. And your predictions in the future are tighter twice now. They're tighter because your model parameters you are very confident about those. And also because you don't have any model discrepancy in the future as well. So you pretend your model's kind of accurate in the future too. So your predictions become tighter kind of twice. And obviously one could set up a toy example where you could show this is kind of in some sense incorrect. The full UQ structure will have predictions going to the future which are more robust, they're wider, and in some sense they're a better reflection of reality. So if I were to just write a paper kind of myself to say this is the sort of structure people should be doing, that's the sort of framework I would do. But as you can see, that's totally UQ biased. So I'm very happy to be.
Could I say? I think there are several different things one could do, and obviously one possibility, and it'd be very welcome, is to write a whole paper that is, as you say, very much UQ centered. I think if we're to keep just one paper in a challenges series whose title is estimation, then I would suggest it wants an introduction which refers to both some of the traditional approaches, but also the importance of putting this in a framework. And then you might have specific challenges, and I would like to see them have fairly applied feet. So, estimation in the early stages of pandemic, estimation, why are you estimating various things? So various challenges, probably most of them at least, being put in a rather traditional estimation framework, as I say, so estimating the early stage of epidemic, estimating the effects of interventions in an ongoing pandemic, these kind of challenges, and then at the end to finish by trying to wrap it together by putting challenges of putting these things together. So in other words, include the mainstream sorts of estimation that are being used and the problems they're being used for, but put it in a framework that says it will be better if we can put all these things together. And I think that would be a very satisfying challenges paper if that could be achieved.
So I think the key issue is whether issues, some of the traditional UQ issues, like looking at the relationship between the model and the world, are part of the estimation process or part of the modeling process. So, because in principle, when someone builds a model, part of their job is to understand its deficiencies and to build that in and to say, well, there will be systematic biases, errors here will relate to errors here, and this is part of them. In principle, it should be part of the modeling process. My only worry about not putting in estimation is if it doesn't go into modeling, it could not go anywhere. But you would hope that in the modeling, that a full, here's my model and here's how it relates to the world. Because once you've got that, until you've got that, you can't really estimate. I mean, if your model has systematic biases and you say, well, that's not my problem, that's a problem for estimation. And then then it seems bizarre to me that you should have a traditional version of estimation that doesn't take that into account and tries to estimate through structural discrepancy while still ignoring it. So structural discrepancy, I mean, ideally to me, is part of modeling. As people build their models, they should be understanding that. And in fact, the more in practice that they find there's big structural discrepancies, the more that should turn them back into to be more careful in their modeling. So they shouldn't really be estimating to the point, until they've decided that their structural discrepancy is manageable and understood. But so I'm very happy to talk about, I mean, in terms of Phil's point, estimation with the understanding that structural discrepancy has already been modeled and understood. And that, as long as it's somewhere in the challenges thing, because that's a key challenge.
Which becomes very evident when, for example, Jasmina compares multiple groups models and they're all different. One can hide from structural model discrepancy. Sorry, sometimes we say model discrepancy, sometimes we say structural discrepancy. They're the same thing, difference between model and the real world. One can hide from it and ignore it when you're working on your own model, but then when you compare to a different group's model and they give an answer which is very different from yours and it's several sigma away on whatever measure you want to use, then you're confronted with it being right there and you can't ignore it anymore. There's nowhere to hide.
And the way you overcome that is that you give the wide ranges that the models give, and then you discuss the point of you are within that uncertainty range of this, and your predictions are only as good as, then you look at the shorter versus longer time scale. Sorry, I'm just thinking through finishing your thought.
Oh, no. What you say is very good, Jasmina. And then we need to be careful at that point as to how you combine those model outputs into actual intervals.
So the point being, we will have in that case, so Oxford has developed this sort of framework, which they're tailoring in the US at the moment, and we're going to do it for the UK, where they take the outputs of the model with the levels of uncertainty and error bounds within a different risk analysis-based framework, which they then analyze.
This is
in the structured expert elicitation thing, which
yes, now, exactly that.
We're going to have another talk about that later on. Not quite sure how much we want to say at the moment. But I guess it's a question of, is it? It will be a part of this whole session on estimation. I guess it's one of the components of the big picture.
Yes.
Yeah, and then the other person, maybe I will email. So the person who probably be leading this would be Christoph Fraser at Oxford, and it might be worth asking him. At the moment, I'm speaking to sort of his group rather than him. Might be worth asking somebody from that group to join. Valerie, Luca Ferretti is not in. Oh, Chiara is not linked in here, right?
I can't remember offhand. Christoph was certainly one of our original invitees, but I don't know that he's ever.
So Will is in his group. Will is in Christoph's group, and
is Will here?
So he's coming next week. He couldn't make today's session.
That's fine. I'm speaking to Will.
Yeah.
So Will is the person who is actually doing the risk analysis. So it's fine. It's great. Okay.
Cool. So I feel compelled to add, and just as to give some sort of meat to some of our discussions here today, when you combine multiple models, that's when the game really gets sort of real and tricky, because that is when, and we've seen this a lot in climate, because there's combining multiple models in climate has been done for years, right? Each country produces their best model, maybe their best run, they try and combine them in certain ways with uncertainty statements. And one has to be very careful, because what you see in climate, and forgive me if there's any climatologists here, but quite often you'll see a bunch of groups which have quite similar climate models. They'll have quite a similar chunk of their model, and they've decorated their atmosphere slightly differently. So you'll get 5 groups giving quite similar predictions and a couple of groups giving different predictions. So the question becomes, how do you combine them? Because they are not just exchangeable models. They are just taking a simple average, giving a simple range is a good start. But really, you need to understand, why are they different? And that's a question about their individual model discrepancy. And that's a question you can answer by saying, these 5 groups have a model discrepancy which is correlated because they have very similar physical assumptions in their model, which may be right or may be wrong. But if they're right, they'll be close to reality. If they're wrong, they're all going to be wrong in the same way, and they're correlated. And hence, when you combine them in a much more nuanced way. And this is a problem which has plagued climate science for a long time. I think there are certain groups getting better at this and doing this in a more structured way. But one must be very careful when one starts combining models, because I saw an interesting talk a few weeks ago in this series about exactly this, lady from America who's doing this. And the key question is, of course, we cut out some models from groups who we consider to be a bit crazy, like, we don't use every model. We trim out the kind of dodgy ones, and we use, about 50 well-respected ones. Well, that's interesting already. You're cutting out ones that you think to be highly inaccurate. You're already making a kind of decision like this. So I just urge there's a note of caution there, which this sort of full UQ analysis gives you a structure and an identifiable reason for why you're combining models in a certain way.
Very good point.
When you're combining models, Ian, often you want to have the conventional and the crazy in both, because this is how the finance and market guys make their money, through the hedging the crazy against the conventional. And if you take COVID is crazy coming in. So if you'd neglected the crazy, you would never have seen it coming.
Yes, and I agree. I always get nervous when people cut things out unless they have sort of good physical reasons for it. If they want to make a statement, I think it's very unlikely.
And I think the combining of models. There's a lot of work going on in the UK at the moment around national digital twins, which is essentially a federation of models. Where these models tend to be at the metadata stage, and unless you can somehow include a level of uncertainty or measure of uncertainty in the metadata, you're never going to sort of join these things together.
Yes, exactly. It becomes hard. It is in some sense the sort of culmination of this style of analysis, because then you not only have to understand your model and its relation to reality very well, you have to do the same for all the other models. But sorry,
an interesting thing.
Which one can do this? So you can do it in a simple way and then a slightly more sophisticated way, and you can walk all the way up. So it's more a question of how much you care.
Yeah, just following up on something that Philip mentioned a moment ago about expert elicitation. We find with a lot of the modelling work we do in defence and energy that we start life at the expert elicitation, and that's essentially doing a uncertainty audit before you start modelling. So because people who've been working in an area, they sort of know what's dodgy and what's known, and if you can somehow embrace that, you have an idea of the uncertainty, and then you start modelling. I think it's a danger if you model something and then at the end you think, okay, what's the uncertainty? You've sort of lost the game a little bit then, in my view.
Yeah, and I think this is sorry, Michael, I'm just going to be, and I think this is something that a lot of the, I'm going to be critical of my branch, but a lot of the epidemiological modelers are not mathematicians or computer scientists or people who understand the technical detail of the model. So the SCIR framework is a very easy framework to just take and simulate for set of parameters for with Bayesian inference on top of it, with distribution, and you just get results. You don't understand the nitty-gritty of the technicality of it, and only sort of what this pandemic has shed light to is why is that been happening so long.
Yeah. So I was going to say that one of the, expert elicitation is clearly important, but you have to unwrap why experts say what they say. And often it is just because they're used to running models. If you ask a climate scientist what will happen in climate, they will think about their climate model and their experiences. So are you just getting basically kind of an echo chamber of the things that you're doing? And to a certain extent, expert elicitation is not just their answer, but it's the reasons they have for giving their answer and the extent to which UQ can support them. Because there are many things when we construct our structural discrepancies, where we do experiments, to inform the people who did the models as to effectively discrepancies that the model has to have, because they have ignored this thing, you know, there has to be at least this amount of error, and it has to be at least as correlated across components. So there is a support. I mean, it's a very interesting interaction between how it all works, but I think that you can't just ask the experts and then take that as a thing that goes in. I mean, it is, again, like everything here, part of the big soup.
I just want to really say thank you, Michael, for saying that, because we have, as you might have seen on the news and in the media, there is new experts coming out all the time, and half of these experts, I'm sorry to say, have never done modeling of epidemiological diseases, do not understand what we are talking about here is estimation and uncertainty. And this is why I have stopped giving news interviews, because what the journalists and the news want is a very clear, precise answer. This is what you need to do, and we are, as we are discussing, we are not in a position to say that.
I see Will Probert joined us recently. Are you there, Will? I'm in the...
Hi, Philip. Hi, everyone. Sorry, I had a trouble with the link, but
yeah, well,
finally figured it out.
You've heard the recent comments, I think, about do experts know what they're doing, really, and how do we
yeah,
how do we take account of it? I mean, you probably have some practical experience of talking to real experts or so-called experts and deciding who to take seriously and how to model them.
Yeah, so I've been involved also in this this exercise where we're combining expert elicitation methods with projections from multiple models and sort of eliciting modeling projections, and then and sort of having multiple rounds of discussion with the modeling team so that you iron out things like uncertainty and their interpretation of interventions, how they're written, and so on. And I'm not sure we've fully answered the question of whether you should allow anyone to take part or whether you should have a more curated group of modeling team, a sort of curated group of modelers involved. I think that's a tricky one. The expert elicitation literature, I think, from my understanding, seems to suggest that a greater diversity of inputs is better. I guess it depends what you define as better. But I mean, going back to Michael's point, I mean, expert elicitation is also used for eliciting causal models. It doesn't have to be used for eliciting sort of estimation of values. And then the experts themselves are being very specific about what the sort of causal pathways are and leading to their estimates. And there's examples that have come out in biodiversity conservation, such as things like forest fires, and what are the leading causes of forest fires and the most important things that would inform something like an uncertainty analysis, as Peter had mentioned. So it doesn't necessarily just have to be about estimating a value or you know, R or the number of deaths and so on.
And Will, I was mentioning that our potential work together about bringing models, what we talked at the workshop last week, or the meeting on Friday last week, about bringing and comparing models and sort of assessing that in that way in the UK.
Yeah, so definitely the framework that we've been working with, if you're interested in the sort of question from the point of view of informing decision making, from the point of view of what should the UK government do, for instance, then potentially the sort of MODS or MMODS, I can share the link, that the framework that we've discussed that combines some of these methods from expert elicitation may be useful.
And I was thinking, the reason why I mentioned it here is because one aspect I was thinking is to potentially use that as the example that we could do in this challenge paper that we'll talk about. So we'll frame out the sort of challenges that we're faced with and then try to address one of them by this method of comparing models. That was sort of how I was thinking for that paper.
So Will, I'm sorry, I wasn't sure if you were there. We chatted about this a little bit earlier. It sounds very interesting what you're doing. The combining of multiple models is, of course, you know, a really important part of the game. how do you handle that combination? How do you handle that combination in terms of if you have models that you suspect maybe have underlying similar structures? So they're not all, you can't just average, say you have 5 models which are quite similar and 3 models which are a little bit different. How do you sort of take account of that?
Yeah, I think these are very important and they're difficult questions. At the moment, we've just been using them as you would use multiple experts. So multiple experts in there, you know, if you've got multiple experts together, you may have 3 from a particular school of training and 3 from another school of training. And from my understanding, I don't think that they're, I mean, you can weight them differently and so on, or you can weight them according to, I mean, some of these methods, Cook's classic method, I think, uses calibration questions. So you sort of throw a bunch of questions at the experts and then calibrate their projections based off those initial calibration questions in terms of, I mean, some ensemble methods use that in multi-modeling approaches as well. I'm sure there's others that know a lot more about things like weather projection and so on.
It's an interesting game, isn't it? It's an interesting game, isn't it? Yes, well, this is what we were discussing, I think, before you came on, is that, you know, if you have some other understanding of why 5 models are quite similar, like, so if 5 models have made similar underlying, in this case, epidemiological assumptions, and 3 other models have made slightly different assumptions, then that suggests a structure that one can use to combine these. So those 5 models, you shouldn't just average all 8 of them, for example, to use a very crass, simple example, but one should sort of downweight those 5 of them because they're essentially coming from the same kind of point of view. So that is the game. This is what UQ tries to provide, but I make no claims that is easy, incidentally. I mean, what that involves is structuring a model discrepancy for each model to say why you think it may be different from reality, and noticing that these 5 models in that case have correlated model discrepancy. And then that dictates how you then combine them to talk about reality. And it will say, because those 5 are correlated, they only get the equivalent weight of, you know, 2 models, say, something like that. So, but you can see the issue and the sort of game. The problem is often people sometimes combine models just by the accuracy of their prediction interval. So you ask modelers to give you an interval, and then sometimes people will kind of weight by that interval. But of course, that is a very dangerous game, because quite often groups will give narrow intervals because they feel it is a statement of sort of accuracy, of expertise if they give a narrow interval. It may not really be quite an accurate the sort of interval you want them to provide you, which is a realistic, honest statement of the uncertainty of their model. So then the game gets very interesting. Perhaps that is a good example for us to look at. I don't know.
Yeah, I mean, that definitely came up in our analysis, where you would have overconfidence in the initial round, and then you would have a discussion and you would have people widening their confidence intervals, because obviously they've taken into account more uncertainty. I guess the way, I mean, what we've been looking at, I guess maybe it's just separating 2 sort of issues. We've been looking at this from the point of view of decision making. So if you're asking models to make projections of different interventions, so there you're focusing particularly on the relative impact of those differences in projections rather than the absolute value. I mean, it's a lot easier question. I mean, you know, it's much easier to predict, is Brexit going to be good or bad for the UK economy, rather than what's the actual change in the in GDP, for instance. You know, so from the point of view of decision making, what we're interested in looking at is where's their concordance and where's their discordance in models. And if there's discordance, you need to drill down into that and find out, well, what are the assumptions? What are the structural differences? What are the causal pathways that are underlying those model recommendations that are going to give different recommendations, because that's essentially what's important to the decision-making problem. So that's sort of how we've been looking at it. In terms of multiple models, I guess, and how to combine them, I've sort of been thinking about this as just an extended sensitivity analysis of what one modeling group would do if I was given infinite amount of time and I wanted to do a modeling project. Then I'd probably run a whole bunch of different models, use a whole bunch of different inference frameworks and so on, but I don't have that infinite amount of time. So you parallelize the process and you get 20 modeling teams to do the same thing, and you combine those results. So it's just a poor natural experiment across different modeling methodologies and inference frameworks.
It sounds like you're doing very interesting things. As I say, the UQ framework provides a sort of structure for that. As you say, how to combine all those different results from groups. It's a question basically about how much you trust each model, what are the similarities between each model, how is each model getting it wrong? And again, the really dangerous question is when all 8 models you're looking at are in agreement for a certain output, they can still all be wrong. They can still all make the underlying scientific assumption, which is incorrect. Sorry, who next? Valerie next.
Yeah, could I just wanted to make a slight distinction, I think, between some of the climate models where you know, there's a difference between taking a standard Met Office model that's been developed over many years, and then different groups will make small tweaks to that model, whether it's initial conditions or running it under a slightly different scenario for climate change or whatever. But basically, the huge structure of that model underlying it is the same. So they're quite highly correlated. And models that have been developed sort of ab initio really by different groups, but using similar structure because that's the structure they want to put in. So, you know, you might have a compartmental model that looks quite similar, but it has been thought through from the beginning. And I think there you've got 2 lots of experts deciding to make some similar assumptions. Whereas in the first case, you've got 2 groups who are saying, we'll trust the Met Office to get the dynamics right. You know, I don't think they're quite comparable in terms of the amount of weight that you want to put on the different sort of setups.
Yes, you're right. An independent group independently deciding to follow the same physical principles gives weight to those physical principles, doesn't it? So one would want to conclude exactly that. That's right. Where the group's just taking a Met Office model because it's easier, they're locked into that structure, and it's maybe not exactly their choice. Yes, I totally agree.
So of course that points out that in the full UQ structure, you need to understand the abilities of the experts and the state of accuracy of the field, which of course is totally. I mean, if these are, you know, I mean, ideally this thing should not happen by estimators doing an estimation analysis, but a smart room with people who actually understand the field and the different views that people have in the field. Because the fact that those 2 did it, was that because those 2 happened to do it, or because that is a consensus built of wisdom over many years? And that's not something that just can come out of the estimation analysis of somebody. It's something that, you know, you need a high level UQ analysis to put all this together, which would be great.
Glenn.
Yeah, so a couple of things. So yeah, one is that I was wondering whether, so I think Will kind of touched on this earlier, that we've very much focused on quantitative sort of description of model outputs and sort of quality of those, but in reality, we're actually kind of interested in qualitative outputs. In terms of, you know, what would the decision change based on this range of models? And if I'm a policymaker and like all the models are telling me to do one thing, then that seems like a much stronger evidence than if they're split. So I don't understand the uncertainty quantification enough, but does it handle that sort of qualitative kind of aspect as well? Is that?
Yes, it's a good question. Yes, I mean, absolutely. In terms of, we often talk about decision support, right? So we hate the idea of dictating decisions to decision makers. What we always talk about is decision support, UQ for decision support, where you can investigate your decision structure and exactly questions like what you said. What decision makers really want to know is, I'm thinking about doing decision A, I could do decision B, it's quite different. Tell me what are the chances in some vaguely defined way that I'm going to really screw up here. So really questions like what you said, that you know, all our models suggest decision A is good. They're all a bit uncertain, they're all a bit inaccurate, but they would have to be really quite wrong for decision B to actually be the right thing to do. So that's a very sort of qualitative, you know, we're not relying on individual numerical predictions from these models. We're just saying a huge cluster of them are just preferring decision A. And now the key interesting thing is when 3 out of your 8 models say decision B is better and 5 say decision A is better.
Yeah.
That's interesting. And of course, when you have a split decision like that, that's when you do have to, like what Will said, you have to dig down and start getting a bit more quantitative, perhaps. But yes, there's various levels one can split this. And if you're interested in sort of looser qualitative questions, then in some sense, I mean, it's on one hand a slightly easier game, but on the other hand, there are subtleties there. So that fits in with this framework, yeah.
But I think you should be fooled. I mean, the fact that UQ looks very quantitative, those quantitative numbers are qualitative. You know, it's not like those really are the number they say. It's just a way of, if you, rather than saying quite likely times quite likely and having a calculus of putting them all together in those, you put these numbers in. But these numbers, you know, you vary them, they're soft. Everything's soft all the way through.
Sure. I suppose like we've been looking at several models, and you know, the fact that they disagree by, you know, sometimes quite a lot in terms of the actual numbers is maybe less important than the fact that they're all suggesting that, you know, certain policies would be appropriate. I guess related to that, I was just going to put a vote in for saying that although having a sort of nice paper that describes a nice framework that, you know, in an ideal world we'd all sort of stick to and use, I think I would put a vote in for saying that something that takes you through and shows how to do the different stages and maybe does the easy ones first. So it's kind of like trying to move the people outside this room, I guess, to actually embrace these ideas and sort of realize that they can be done relatively easily in some cases, and then other things are much harder. And I think kind of a paper that is open about that and kind of tries to encourage people to do the easy things at least would be really valuable.
That is a very good point, and something I worry about deeply. We don't want to be in our sort of, you know, in our ivory tower preaching what people should do, when people are very pushed for time and everyone's working very, very hard and doing the best they can. So I do like the idea of a more of a sort of tutorial paper, a kind of this is how walking you through the steps. Some of our papers we've done in the past have been a little bit of this ilk. The nice thing with all these structures, there are easy versions, medium versions, hard versions. So with model discrepancy, there's a very simple thing that everyone can do in 10 minutes. And then there's a slightly better thing that one can do with a few more runs of your model, a few more experiments. And then there's the really detailed stuff that requires sitting down with experts and really thinking about it. So perhaps a paper which gives those simple examples for each part of the structure. So anyone can just take their model and put that in. You know, and then get the benefits of the slightly more medium version, etc.
I think that's a really key thing. I think if we can do that, if we give it almost like an overarching how to do primer style paper by illustrating components, because some of us are obviously working in this area and doing this sort of hands-on, straight on, do it by tomorrow, this modeling analysis, and we kind of know what that entails. So yes, I agree.
So I think that the huge challenge is that in one sense, you can show people relatively simple things that would make what they do better. And that's really important to tell them. But there's another level where the whole world is throwing the whole world economy down the drain effectively because of the failure to do a careful analysis. Well, not because of, but I mean, a careful analysis would be hugely relevant to this. So I think we also want to set our flag to say, you know, that rather than people crazily rushing around, you know, who are being under-resourced, having to get crazy numbers by tomorrow, there is a scope for actually putting a proper amount of resource, which is minuscule, to doing a proper job, to actually supporting, you know, a really serious attempt to do this.
Just to say, Michael, I think the groups that are sort of you heard about recently that have been working and have been producing results, they have the expertise, they have the technical. So when I was mentioning that some people coming on TV are not experts, I wasn't talking about the people that, so they are expertise, and sort of, even though this is a timely response needed by some of these groups, the expertise are there and the model structures have been there. It's about churning results as you recalibrate till yesterday rather than 2 months ago, and understanding that concept. But I do get your point.
Michael is going further, as he always will, meaning the full expertise in the statistical sort of framework and skills. To put this in place is hard to do at the last minute. there's a huge amount of epidemiological expertise and modeling expertise, and that is huge. We should never sort of diminish that. But we would feel that the use of those models, they're not being fully utilized because they're not being embedded in the correct uncertainty structure. Sorry, Philip's been waiting for a while.
Yeah.
Philip.
Valerie was before me, I think.
Oh, sorry.
Well, I don't know. It was very quick anyway. It was just to say that in thinking about the challenges, we're not necessarily thinking about things which are relevant immediately. I mean, at least some, we're thinking about challenges for the future. What you try to put in place that will help in the future. So it's not necessarily reacting here and now with people who are already overstretched.
No,
But
I think
anyway.
it's hugely important. Yes.
Yeah.
Philip.
Yeah, I was going to say something similar. Challenges, of course, depend on who they're focused at. I mean, we can say there are challenges for the people who don't really know what they're doing to get up to speed, and we've been talking rather as if that's what we're addressing, that, you know, we have a lot of answers and we'd like people to take account of them. But I think we face challenges ourselves as researchers, which is we don't have all the answers. And one of the things we might start thinking about is where are the gaps in what we think at the moment, and what are the challenges for further research?
Well, this is true, and this is a good point, because we're talking about two different directions here: a sort of tutorial style paper with an easy walkthrough for epidemiologists to follow, a sort of, I was going to say a fairly well beaten path. It's not that well beaten, but anyway, well trodden path. Sorry, but that's one style of paper. Whether a challenges paper is more, as Philip says, is about what's not been done, or perhaps what structures are not in place for the epidemiological community. Perhaps there's a sort of intermediate challenge, which is just there is structures and expertise that is just not in place and available for a fast reaction epidemic style problem. But then there's the broader question, as Philip alludes to, of the statistical structures that have not been invented yet, of which there are.
And of course, they're not just statistical structures. I mean, this is the whole point. I mean, the statistical structures are not separate from the modeling structures. And to me, the fundamental challenge is almost an organizational challenge of how from day one, the models are built so that the full analysis, you know, will, I won't say seamlessly, but will in a principled way be carried through, so that in some finite timescape, you know, people can say, we have reasonable confidence that these things actually do what they say they're supposed to do. And how that is, I mean, organized across communities, and how communities prepare themselves for this and agree to do that is the fundamental challenge, I think, but it's one that we should be sort of addressing.
And I think we will address that, but that's, I think, maybe more in the challenges paper than here, was my thinking.
I think it sounds a bit as if we might be thinking in two different directions, and maybe there are two papers here. That the challenges paper, as I think we envisaged, which would be the longer term, really quite high level specific challenges where more work needs to be done by the statistics, mathematics, epidemiological, whatever communities. And something, I mean, I'm putting two extremes here, and the other, which would be the more tutorial idea of how we might do this now.
Yeah. So let me put this, okay, I'm going to have to go soon, but let me just put this in some more framework. I mean, if you compare, for example, model building with experimental design, so it used to be people would just do experiments. They bring to the statistician and they'd say, statistician would say, I wish you hadn't done that experiment. You should have talked to me before that, okay? And experimental design, the notion of experimental design is baked in to how you do experiments. Yeah, then effectively, I think we need that same kind of culture change with how you construct models for complex phenomena. You know, it's not, you do the model and then bring it along and we will do a UQ analysis for it. That's just a terrible way of thinking about it. And the big challenge is and how we exactly do that, I think, you know, is a big open question, how you design models for this. But that to me is a thing that we need to do.
I think one of the modeling challenges to me is what sort of models you construct. I mean, thinking right back at the beginning, you know, given a certain setup, how much complexity is it a good idea to put in? How much do you need for any specific purpose? Do you know, how robust are the conclusions of a very simple model as compared with, you know, something that's all singing and all dancing, but maybe is unnecessarily complex for the specific purpose? You know, to what extent a simple stochastic model will do as compared with, you know, an agent-based model with, you know, a lot of detail. And I think there are a lot of questions even to be answered there before you start thinking about any sort of detailed model comparison.
And
If you,
sorry.
If you start with uncertainty, you tend to build up the complexity of the model where you need it. So if you're making decisions, you start off with something which is reasonably simple and perhaps trusted and perhaps meaningless for decision making, and then you build up fidelity in certain parts of the models to respond to questions that are being asked. And at some day in the future, you end up with a complex model that you can trust because you have built it up, always keeping an eye on the uncertainty associated with it. But you can only do that if at the beginning you say, I'm uncertain about what I'm doing, so let's start understanding that uncertainty better. And I'm sorry, Ian, I'm not familiar with the UK the UQ framework, but if that framework does that, then it's the right place to start. In our work, we always start with uncertainty, and then we build the models to try to reduce that to support decision making.
So my view on that is that the complex model in some sense will be better, except that you can't necessarily fit and estimate it. Because, you know, if I model every single person in the country, well, it would be great if I got it right, but yeah. However, I mean, the problem with a simple model is it ignores issues that the complex model can reveal. So really, these things are not alternatives, they're complements. You fit.
I agree with you, Michael, but what I would say is, in my limited experience, I've never seen a complex model that didn't start off simply.
Can I just agree with Peter's point, but give an example? So in the SEII framework, it has been used across a number of infectious diseases. What it hasn't been used before is for contact tracing. And so when we started off, when contact tracing became as a sort of a intervention that needed to be looked at, loads of people just went on and built an agent-based model, which is sort of the realistic way to do it, because you track individuals in an individual-based model. But there is a concept there that was very easily to extend an SDIR model with a probabilistic framework within that, where you can track exposed and infectious people, which is what my group did. And I was very surprised it has not been thought of getting done before. So I am aware of Fraser, of Christoph looking at it at some point in a paper back in 2005, 2006 for the swine flu, but wasn't extended. And so this builds the point about when you decide to answer a question, do you build a model to answer that specific question, or do you step back and you think, what possible question I may be asked with this framework, and build it with steps of uncertainty, as Peter said.
I like it. So, okay, so I think we've got to think about what we want to take away from this meeting. So we've covered a lot of interesting topics, and I would say increasingly diverging topics, I think, which is fun in itself. Is the primary goal, if I can ask Valerie and Dennis, I mean, the primary goal is this challenge paper. Obviously, we can decide to write whatever papers we wish. We are academics after all. But the primary goal is a sort of challenge paper, yes? Is that also?
That was our thought. That sort of concept has worked well before, and we thought it might fit here. And the idea, I suppose, is to sort of identify challenges for the community and say a little bit about them, and then sort of put them out there as things that one hopes that people will work on and perhaps, you know, address those challenges. But But as you say, I mean, other things are possible too. That was what we had in mind for this series of challenges papers, that we might try to do that.
I guess I can maybe summarize. Sorry, please go on.
I'd agree with that, except but also, of course, writing these challenges papers isn't the only remaining thing we want to do during the program. And if as a spin-off activity, people wish to write a separate, collaborate in writing a separate paper, that's fine. It's just I think the I think if we're going to have the challenges papers, they do want to follow a format. I mean, don't want to be slavish about it or too precise, but I think it's trying to identify fairly specific problem areas where you could see mathematicians, modelers, whatever, getting together and doing work over the next 5 or 10 years, which would improve understanding in that. And either tutorial stuff or perhaps very narrow specific research aims are better pursued as a separate paper.
If I can just summarize, I think the issue here, of course, is we're talking about challenges for different communities here, right? So
yeah,
the challenges for current epidemiological community in reacting to a rapid onset of a pandemic is one particular set of questions. Whether the sort of longer timescale challenges of the entire, call it whatever you will, collection of modeling, UQ, statistical, mathematical, applied maths, whatever you want to be, a community, as to long-term sort of problems in how we analyze complex models and relate them to reality. Those are very different questions. And the former question.
But I think in that direction, I would want us to be holistic. I think we really do want the flavor of it to be, what are the problems that need to be faced if we're to do better in dealing with future pandemics? And so it may well be that the specific challenges should be within a sort of, roughly speaking, let's say a sort of mathematical sciences framework, but still they could vary hugely from, we might have one challenge, which is saying which could be a challenge to theoretical statistics, if you like. It could be a challenge to the UQ community, saying that UQ is great, but it hasn't really got the tools to help us with future pandemic modeling. So, there could be quite a theoretical statistical challenge there. And then at the other extreme, there could be a very much more applied, medically, epidemiologically focused challenge. I think, but then if it was, say, a political challenge or sociological challenge, then it might be something we'd want to refer to in the introduction or discussion, but it would be perhaps out with the focus of the specific challenges we'd have. But I think, for me, part of writing this challenge series is to try and disentangle who it is who should be trying to, which field of science is going to be helpful for which problems. And okay, that's
I think that, I heard Ian just say what I think is the challenge a moment ago, which was, how do you relate complex models to reality? Because that is the essence of how you improve capacity for decision making and action. People need to trust complex models. So how do you link them to reality?
And that's a great title, Peter. Sorry, I'm to interrupt you, but that's a great title.
How do you trust complex models?
How do you relate complex models to reality?
Because that is, dare I say it, the essence of uncertainty is quietly removing that uncertainty so people trust what you're telling them.
I like that title.
And in situations like, and I was just listening to you while you were talking.
Yeah, so I have to go. Challenges, put the challenge high, man. Don't, yeah. Big challenges.
Okay, thank you, Michael.
Thanks, Michael.
Okay, take care.
Bye.
Right, now Michael's gone, we can do exactly the opposite of what he said, okay?
I was going to say to Michael, but he disappeared too fast, that we are setting up a Slack channel for collaborative work for each of the each of the challenge themes. So, which is a place you can post ideas for specific challenges, papers we all ought to read, or whatever.
Yeah, Dennis, I did this already. So yeah, I've set it up and I've invited, I think most of the people on here, there are a few names that I have down that I couldn't find, but I'll have a look for them again.
Hopefully, we did mention this before you joined us, Dennis. So I think hopefully, I'm not sure whether Michael was there then, but I think he was. But hopefully he's already on the Slack channel and we'll get an alert from it. Was he one of the people you didn't find?
No, I found him.
Yeah, so I think he's already there. So it should be okay.
Okay. Well, I guess time is pushing on, but that sort of paper title of how do you link complex models to reality is an attractive title.
That was going to be my title for the challenge paper. I'm joking.
Maybe it's a title for the collection of challenges.
I think it's a title for the collection because it really narrows it. It really says what we are talking about.
Yes.
And sorry, and then you have how do you, and then you give answers in each of these papers per, as Dennis said, a discipline that could answer a step of these puzzling how we answer it.
I would agree with that, but one of those papers has to be the overarching, description of how all this fits in. So it's because I think how you link a complex model to reality is there has to be this overarching view, and then expertise plugging in all these pieces. But the pieces don't quite make the whole. One needs the kind of overarching viewpoint at some point in one of these papers. I'm not saying it's our one, but at some point one needs to put that in. Cool. Well, that's tricky. This gives us choices as to how to proceed. Our topic is estimation, but we've been talking really about the whole game, the whole thing here. I think it's pretty clear which direction I want to go in, which is a paper on the framework. But I don't really want to push this. I don't know how everyone's feeling. Does anyone have any kind of last thoughts about, let's just restrict it to what we are going to do, this paper, this kind of group here?
It might depend a little bit on how the discussions with the rest of the estimation area go, and the modelling too, I suppose, as to where we end up really feeling the divisions should come. But
can I suggest just following up on what Dennis and Valerie had said earlier? So with regards to the Slack channel, it might be useful just initially for people to just write down sort of the challenges that they see, and whether or not they fit with estimation or somewhere else. If we just have them in a Slack channel somewhere, then we can sort of at least document them and start putting them together. And I guess it's Dennis and Valerie, feel free to sort of jump in and say if this isn't what you kind of want. But I sort of saw this challenges paper is this a chance for everyone to take this step back and look at it from a broader perspective. Everyone's often focused on what we can do right now to improve the situation. But I kind of think of it as like, imagine there was another pandemic in 10 years' time. What things would we want to have set in place from our experiences this time to make sure that we can deal with it better, so that we're not having the same conversations in 10 years' time? So I guess it's those kind of challenges which are a bit more focused, and maybe challenges in things like bringing communities together, and maybe that doesn't fit in the estimation challenge, maybe we put that somewhere else, but all these are important. So just, I think if people can start writing them down somewhere in the Slack channels, that's probably a good place to start.
I think that sounds very good, but I think we shouldn't discount the idea that these discussions might generate ideas for other things, another paper that would be really good to write, that like the more tutorial thing that you described, for example, or whatever, but something much more specific that doesn't necessarily fit directly into what we perceived as this sort of challenges series, but nevertheless would be really good to do, and we might have the right group to do it. So I think we should sort of keep both.
Yeah. No, sorry, Barry. Yeah, I completely agree. And I would say if people do want to write papers or want some facilitation in setting up meetings, they're more than welcome to just drop me emails and we can help in whatever way we can to do all the papers. I guess I was just thinking, just to try and really get the challenges papers really started, it would be good just to start writing some stuff down.
And two things. I mean, I would encourage people to put down, I mean, among other things they may want, anything helpful they want to put in the Slack channel is welcome, of course, but if they're putting down challenges, not to worry too much as to whether that channel belongs in this particular challenge paper. It might end up being shifted to modeling, but the point is to be inclusive, to get the ideas down, and they're easier to delete than to resurrect if someone else has deleted them. And the other thing just to say is that for those who haven't looked at it, they might like to look at the Epidemic Challenges volume from 2015. It's I think it's on, you find it on the Newton pages. I'm sure we've given the references, but I can supply the reference if people have.
Yeah, I think we put it. I think it's in the Dropbox, isn't it, for the workshop?
I think there was also a link on one of the bulletins.
Anyway,
but
just to have for people who haven't never looked at that, I think if they had a look at whatever a selection of the papers that are of interest to them, they could just get an idea of the kind of format we had, and so that's the kind of format we're again suggesting. Though of course, if people want to look at all that and say, well, you could improve that format, then do suggest. But it did seem a good way of covering a whole wide range of things in a fairly consistent manner. So.
I think it also had the advantage that within one paper, you might have one or two people taking charge of a particular challenge, but that challenge would only occupy a paragraph or two, at most a page. So one's not trying to get people to spend a lot of time writing a big paper, but to be quite focused on describing specific challenges and the sort of context of them. I mean, obviously they take a lot of honing, but it's sort of manageable in a way which everybody is very busy, but they might be able to spare enough time to do this sort of thing where they couldn't write lots and lots of different papers.
I think that does lend itself to collaborative working, because you end up with, once you've identified and agreed specific challenges, it can be one or possibly two or three people who write a specific one, and then we look at it as a group, and maybe all of us together discuss what needs to go in the introduction discussion. But I think it should be easier than some of the things we've been trying to do earlier in the program of collaborative groups writing a whole paper, which is quite tricky, where you all have an interest in every part of it, and so it sort of brings some sort of order to which simplifies things a bit.
Peter, you had your hand up a while ago.
Yeah, I was just sort of thinking about relating it back to the original title of this group. If the challenge is relating complex models to reality, the threat to that is uncertainty. And so somehow we need to quantify uncertainty. Now, whether that is through Ian's framework, whether that's through audits, whether it's through any other different way, if the existential threat is uncertainty, that's the thing that we need to tackle. So by going from the challenge of, because I want to make decisions. So I want to relate complex models to reality. I've got to deal with uncertainty. How do I deal with uncertainty?
I love it. That's very much our worldview, is the decision that drives you, and everything flows down from there, and it alerts you to the fact that the uncertainty is so important and critical. Okay.
Because
sorry, please.
Decision making, when you're in a threat position, when you have to make decisions. And so a bad decision is better than no decision. But once you've made that bad decision, you want to know pretty soon how you can improve upon it. Mm-hmm. And you do that by just keeping an eye on uncertainty all the way through.
Okay, can I make a small suggestion? So listen, this has been really useful, and I think we should probably wind it up pretty soon because people are probably getting tired. But this has been really useful. Thank you for everyone's input. But can I give people a little bit of homework if you want to sort of engage and keep things going, because these meetings are wonderful and it's very easy for us to drop off and forget about some of this stuff. But I think I would like to give everyone a bit of homework, which is A, find the Slack channel for this estimation UQ group. And B, what I'd really like, because I was worried that everyone talks and some people may have some really interesting ideas which haven't quite found their way out. What I'd really love is for everyone just to note down a few of the kind of core points, core challenges that perhaps we were discussed today, and you just want to reiterate that they're important for you from your perspective, whether it be an epidemiological modeling perspective, be it whichever area you're in. So you can just reiterate a few of the things we've discussed and say, I think we really need to hit these guys. Or feel free to add in any other challenges that we've just not had time to talk about. So what I just love is for people just to engage. 3 bullet points is all that you need. Find the Slack channel, 3 bullet points. Just say which things are closest to your heart. Imagine we wrote the challenges paper and we didn't include one of your bullet points. How sad you would be. Put it down now and we'll try and get it in. And perhaps we'll get a little bit more of a consensus over like the critical ones that have to be in, and then some of the other optional ones which would be in. Does that sound okay with people? If you don't want to engage, that's no problem at all. This is a nice, easy way to make sure you get in, and we just start the conversation and keep it going. Does that sound okay?
Yeah, I think that's fine. The excellent suggestions. Some people have already gone. Others may not have a very good memory of what was being said. Can you put that in writing? On the Slack channel?
No problem. No problem.
Can I just ask Kira, do you know when we might get the access to the recordings? Because I was just noticing that Leon's, I think, just joined us quite recently and will have missed most of this, and then there may well be others. So I was just wondering what the time scale is for the...
I think they should be up like by tomorrow or even by later today. I will post it in the Slack channel as soon as I see that it's available.
That would be super. Thank you. Yes, thank you very much.
Fantastic.
Okay.
Right. Well, I'm good. Does anyone else have anything burning they want to say?
No, thanks very much, Ian.
Thank you very much. Thanks for leading it, Ian. That was great.
Oh, no problem at all. No. Well, thank you for everyone for engaging. It's a really interesting debate, and I really hope we can push this forward.
Next Friday, if not before.
Well, hopefully before. Hopefully this afternoon.
Okay. Yes, 3 o'clock this afternoon for more modelling chat.
Indeed.
Right. Okay.
Great. Thanks all.
Thank you very much. Bye. Bye-bye.